Good morning students. Welcome to SA-1 revision day 3. So today we are going to discuss chapter 3 LCM and HCF. Okay, what is LCM? Least common multiple. HCF means highest common factor. Before stepping into that, in the first Roman we have blanks. Let's discuss them. The numbers having 1 and itself as factors are called prime numbers. Okay, prime numbers. The numbers having 1 as common factors. Which numbers having 1 as common factors? Co-primes. Co-prime numbers will have 1 as common factor. Dash prime numbers are there between 1 and 100. How many prime numbers are there between 1 and 100? 25 are there. The HCF of two co-prime numbers is always 1. For example, if we take 5 and 7, common factors of 5 and 7 is 1. Co-prime numbers means here only we discussed co-prime numbers have common factor 1. So if you find the LCM for 5 and 7, you will get 1 only as HCF. Okay. The LCM of two co-prime numbers. If you find the LCM of any two co-prime numbers, we will get their product as LCM. Their product. See here. Don't confuse for these two students. If you take two co-prime numbers, their HCF will be 1, LCM will be their product. Product means whatever numbers you have taken, if you multiply those two numbers, you will get their LCM. Okay. Next, HCF of 20 and 25. We cannot see and answer this. We have to do the problem. See, HCF of 20 and 25. You know how to do HCF, right? Long division method is the best way to find the HCF. In 20 table, 20 ones are 20, 25 minus 20 is 5. Then what to do? It's a before divisor, you should bring it. It's before divisor 20, we must take here. In 5 table, 5 fours, 20. You should not take this as an answer. This is HCF. The last divisor is HCF. Okay. So the HCF of 20 and 25 is 5. LCM of 20 and 25. This also we cannot answer by looking at this. We have to find it. So how to find the LCM? Short division. This is long division. This is short division. So 20 and 25 both are divisible by 5. So here we are finding LCM. Is it clear? So in 5 table, 5 4s 20, 5 5s 25. Okay. And 4 comes in 2 table. 2 2s are 2 5s are. Here all are prime numbers, right? So we can stop. Then what is the LCM? LCM is 5 into 2 into 2 into 5. 5 into 2 into 2 into 5. We know 5 2s are 10. 2 5s are 10. What is 10 times 10? 100. So what is the LCM of 20 and 25? 100. Now, LCM into HCF. This formula we learnt at the time of regular classes. LCM into HCF equal to product of two numbers. Product of two numbers. LCM equal to product of two numbers divided by HCF. And one of the numbers equal to LCM into HCF divided by other number. Other number. So you need to learn all this blanks. Okay, next. Second Roman, find the HCF of the following. Let's do. From this Roman, I will explain you two questions. You have to do the remaining all. Okay. Let us find the HCF of 30, 60 and 75. See how to find the HCF. As we discussed, the best way is long division method. How to use long division method? First you take 30 and 60 and do division. 30 and 60. 30 2s are 60. See, in the first step itself we got 0. So what to do? The last divisor and the leftover number. You take these two numbers and again you do long division method. 30 table. 30 2s are 60. And 75 minus 60 is 15. And then what to do? It's a before divisor must take. So 30 we must take here. 15 table. 15 2s are 30. Okay, we got 0. So problem finished. Then what is the HCF? In the second long division, the last divisor is the HCF. Therefore, HCF of 30, 60 and 75 is 15. Then I will explain one more question. Second question from our worksheet is find the HCF of 32, 36 and 48. See, I prefer always long division only. First let us do long division for 32 and 36. 32 table 1s are 32. 36 minus 32 is 4. And then we must take the before divisor here 32. In 4 times table 4 8s are 32, right? We got 0. Okay. First two numbers HCF is 4. Then what to do with this HCF? You have to do long division for 48. In 4 times table 4 12s are 48. So in the first step itself we got 0. So no problem. What is the HCF? The last divisor. Therefore the HCF of 36, 32 and 48 is 4. Okay. Then the remaining problems you try as homework. Third Roman, find the LCM of the following. So here also 6 problems are there. I will explain 3 questions. You have to try the remaining 3. See, first one 16 and 32. So the better way to find the LCM is short division. And here you have to take always, you have to prefer always prime numbers. 16 and 32 divisible by 2. In 2 times table 2 8s 16, 2 16s 32. Now 8 and 16 are also divisible by 2. 2 4s 8, 2 8s are 16. And then 2 table again 2 2s are 4, 2 4s are 8. Again 2 and 4 comes in 2 table. 1s are 2s are. So here we got prime numbers, so we can stop. So how to find the LCM? You have to multiply all these numbers. How many 2s are there? 1 2 3 4 5. 2 into 2 into 2 into 2 into 2. 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32 is the LCM of these two numbers. Okay. Second problem, 93 and 124. So to these two numbers we have to find what is the LCM. Then we have to check in which table these two numbers will get. Then for these all we have to check whether this number comes in 2 table. No, as it's an odd number. Then these numbers comes in 3 table. No, because 124 won't divisible by 3. Then if you check like this in one after the other prime numbers, you can identify that these both the numbers divisible by 31. See, in 93, in 31 table 31 3s 93. In 31 table 31 3s 93. And table 31 4s. See, 4 1s 4, 4 3s 12. So in 31 table 31 4s 124. Okay. Now here 4 is divisible by 2. In 2 table we won't get 3, right? So let's write 3 as it is, and 2 table 2 2s 4. Okay. So what will be the LCM? Here we can stop as we got prime numbers. So the LCM is 3 into 2 into 3 into 2. 3 into 2 into 3 into 2. So 3 2s are 6. Again 3 2s are 6. So 6 times 6 is 36 is the LCM. Next. 192, 188 and 576. In which table these 3 numbers will get? See, if we see, we can identify that all the 3 numbers are even numbers. All even numbers divisible by 2. So let's take 2 table. In 2 table, how many times is 192? For that, no need to do like this normal division. Let's check here itself. First you take 19. In 2 table, how many times is near to 19? 2 9s are 18. See, out of 19, 2 9s are 18 over. Still 1 is left. No, that one you have to carry to this 2, which becomes 1 to 12. Then in 2 table, 2 6 are 12. Okay, next 188. First you take 18. In 2 table, how many times is 18? 2 9s 18. And then 8. How many times is 8? 2 4s 8. So that means into table 94 times is 188. Next 576. Into table how many times is 576? Let's check digit after the digit. Into table 2 2s are 4. Still here 1 is left. That 1 if you give to the next digit becomes 17. Then in 2 table how many times is near to 17? 2 8s are 16. Still 1 is left. That 1 you have to give to the next digit which becomes 16. So in 2 table 2 8s are 16. Okay. Now again we have all even numbers. So we can take again 2 table. Table how many times is 96? Let's check how many times is near to 9. In 2 table 2 4s 8, right? Now 1 is left. 1 if you carry to the next digit which becomes 16. 2 8s 16. Now in 94 2 4s are 8. 1 is left. That 1 if you carry to the next digit it becomes 14. 2 7s are 14. And then in 2 table 2 1s 2. 2 4s 8. Again 2 4s 8. Okay. Here 47 is a prime number. So leave this 47 and think about the other two numbers. These two numbers are even numbers, right? We can take in 2 times table. In 2 times table 2 2s 4. 2 4s 8. As it's a prime number, let's write as it is. Now in 2 table 2 7s 14. 2 2s are 4. Okay. Next. Again 2 table. 2 12s are, as it's a prime number, we have to write 47 as it is down. And then in 2 table 2 3s are 6. Still 1 is there. That 1 if you carry to the next digit becomes 12. Then 2 6s are 12. Now again 12 and 36. Again 2 table. 2 6 are 47 as it is. 2 18s are. And then 6 and 18 divisible by 3. 3 2s. 47 as it is. 3 6 are. Again 2 and 6 divisible by 2. 1 time 47 as it is 3 times. So now here we have all prime numbers. So we can stop the procedure and multiply all the leftover numbers. What are left? 1, 2, 3, 4, 5, 6. 6 times 2. 1, 2, 3, 4, 5, 6 times 2. And then 2 times 3 and 1 time 47. Okay. Then we have to multiply all these numbers. See, 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32, 32 2s 64. Till here we will get the product 64. 3 3s 9 into 47. So let's multiply 64 into 9 into 47. If we multiply all these numbers, we will get 27,072 as the product. So in this Roman still we have some more problems to find the LCM. So you have to complete all those. Okay. In the next Roman we have word problems. See, the product of two numbers is 1536. Their HCF is 16 and find the LCM. Okay. See here HCF 16. Product of two numbers is 1536 and find the LCM. See, we know already when we have HCF and the product of numbers, how to find the LCM. First let us write given. What is given? HCF is given and product of two numbers also given. Product of two numbers is 1536 and then we have to find LCM. We have formula, right? How to find the LCM? LCM equal to product of two numbers by HCF. So product of two numbers is 1536 by 16. So you have to do the division for both the numbers, then we will get the required answer, which is LCM. See, in 16 table we won't get 15. So let us take 153. Now let's check 16 8s, 16 9s, which is suitable. We will try. 8 6 are 48, 4 8 1s 8 plus 4 128. 9 6 are 54, 5, 9 1s are 9 plus 5, 14. So what is the nearest? 128 or 144? 144 is near to 153. So 9 times is 144, and then 153 minus 144 is 9. Okay. Then bring the next digit down. Now in 16 table, how many times will be 96? Let's check. In 16 table, let's check 6 times. 6 6 are 36, 3 carry, 6 1s are 6 plus 3, 9. So in 16 table, exactly 6 times is 96. So what is the answer? 96. Therefore the LCM is 96. Next question. Find the greatest number that will exactly divide 1065 and 1491. Okay, see here, if you see in this question, we can see a keyword called greatest. See, in HCF, H stands for highest, right? Highest. So greatest is also similar word to HCF. So the clue in the question is you have to find the HCF of these two numbers. This is a clue. If we have the word greatest, longest, highest, such kind of words, similar meaning words, then we have to find HCF. Okay. So what we have to do? The required number is equal to, we have to find the HCF of 1065 and 1491. So second one solution, the required number equal to HCF of 1065 and 1491. Let's do the HCF now. So 1065, 1491. Now 1065 once only, it's near to 1400. So borrow. 11 minus 5 is 6. 8 is left. 8 minus 6 is 2. Here 4 and 1 minus 1, 0. Then what to do? We have to bring its before divisor here. 1065. Now in 426 table, how many times will be near to this? Let's check. 2 times, 12, 1, 5, 8. And better to check 3 times also. Okay. 18, 1, 7 and 12. So check out how many times is near. 2 times or 3 times? 2 times is near, right? 852. 5 minus 2, 3. 6 minus 5, 1. 10 minus 8 is 2. Then what next? Let's take its before divisor now. So 426 we should take. Now in 213 table, let's check 2 times. 2 3 6, 2 1s 2, 2 2s 4. So exactly 2 times is 426. So what is the HCF? 213. So the required number is equal to 213. Next. Third question. The product of two numbers is 2286 and their HCF is also given 9. Find the LCM. Same type of question we discussed just before, right? So let's answer this. Product of two numbers is given, HCF is given. Then how to find the LCM? What is the formula, children? We know the formula, right? Product of two numbers. PR dot means product of two numbers by HCF. So 2286 by 9. So let's do division for these two numbers. Into a 9 table, 9 2s 18, 22 minus 18 is 4, and bring the next digit down. In 9 table, 9 5s 45, and then 48 minus 5 is 45 is 3, and let's bring 6 down, and 9 4s are 36. So what is the answer? 254, which is the required LCM. Okay, next. Find the smallest number which is being added 5 to it is exactly divisible by 9, 21, 25 and 45. Can you identify what's the keyword here? the smallest. When we have the keyword like smallest, least, small, we have to find LCM, because in LCM also L stands for least, right? So it's a similar word to smallest. So first we have to find the LCM of these numbers, then I'll detail you what we have to do when we have this extra sentence. Okay. First, let's do the LCM. See, if we see here 9 and 21, 45, these three numbers divisible by 3. So let's take 3. 3 3 is 9, 3 7 is 21, and in 3 table we won't get 25. So let's write as it is. In 3 table 15s are 45. Now if we see 25 and 15 divisible by 5. So let's take 5. In 5 table 3 and 7 won't be, right? So let's write 3 and 7 as it is. In 5 times table 5 5s, 5 3s. Now 2 3s are there. So let's take 3 table. 3 1s, 7, 5, 1. Now the remaining numbers are only all prime numbers only. So let's find the LCM. So 3 into 5 into 3 into 7 into 5. So tell me children, 3 5 is 15, 15 3 is 45, 7 5 is 35. So let's multiply 45 and 35, where we will get the final answer 1575. And in the question a word is added. What is that? On being added 5 to it. See, added 5 means after finding the LCM you have to subtract 5. LCM minus 5. So 1575 minus 5, which is 1570. Okay children. So with this question we discussed maximum concepts from this chapter. So what is your duty now? Simply watching the video and leaving. You have to take your homework book and practice all these problems. Whatever I explained, you have to do along with that. Extra questions also there in the worksheet. Those also you need to complete. Thank you.